Hey, it's Mrs. Blankenbeckler again, and this is a video on 406 and 407 in Geometry 203B, and it's on inscribed angles and arcs. So this is the lesson over that section. So let's go over inscribed angles and inscribed arcs first. Okay, first thing, here's our circle, because we're doing circles. Let's talk about what a central angle is and what an inscribed angle is. Okay, it's all about where the vertex is. If I have a circle and my vertex is at the center, I call that a, drumroll Eddie, central angle. And the central angle has the exact same measure as the arc. So if the angle is 40 degrees, the arc measure is also 40 degrees. So that's central. Vertex at the center. Okay, now what's an inscribed angle? Inscribed angle has the vertex way back here on the circle. So the vertex is on the circle, not inside the circle. Now, let's talk about the angle measures. The angle measure of this angle is going to be half of the intercepted arc. So on this diagram, I have this inscribed angle, and its intercepted arc is the arc inside basically the mouth of the angle. So this arc is 40 degrees. The angle is going to be half, so it's going to be 20 degrees. So that's how the inscribed angle is different, and it makes sense because it's back further, so it's smaller. Doesn't that make sense? So this one's wider, central angle's the same. This one's smaller, it's half because it's twice as far away. Kind of makes sense. So you would maybe use this in surveying. If you're one of the surveyors on the side of the street, that's when you would use these inscribed angles. Okay, so let's do a couple of examples. Let me get the dark green because it's a little bit easier to see on here. Okay, so let's say that we have an angle here, and I'm going to mark these two arcs as congruent. Now, they're not that pretty, so they don't look congruent, but I'm going to put 100 degrees over here. And I want you to find the angle measure at X. Okay, let's kind of do some analyzing here. If this arc is 100 degrees, what do we know this arc has to be? 100 degrees because they're marked congruent. So far I've got 200 degrees accounted for. How many degrees are in a whole circle? 360. So I have 360, and I'm going to subtract these two. So I'm going to subtract 200, and I have 160 degrees left. That means this arc right here is 160 degrees. Now, it's not drawn to scale, but that's okay. Okay, 160 degrees, and this is an inscribed angle, and this arc is the intercepted arc. So if I extend those sides, you can really see this arc that's inside the mouth of the angle. Well, if I go all the way back to the inscribed angle, it's half. So that means X is 80 degrees. So my angle measure, and you can't read that very well, so I'll do it in a little bit darker green, is 80 degrees. There we go. So that's how you work an inscribed angle. So that's our first type, just basic inscribed angles. Now let's look at one. We're going to throw some variables in there. Okay, so let's say here's our angle, and this angle is X plus 5, and this arc associated with it is 3x minus 40. Okay, what do we know? What's the rule? This arc is twice the measure of this angle. So I'm going to double the angle and set it equal to the arc. So let's just put numbers in there for a second. If this is 50, the arc is 100. If this is 100, the arc is 200. Okay? So I'm going to take and double the angle and set it equal to the arc. So I'm going to take x minus or plus 5, and I need 2 of those. So times 2 equals 3x minus 40. So there's my equation. Then we just solve it. 2x plus 10 by distributing equals 3x minus 40. Subtract 2x. Subtract 2x. Add 40. Add 40. So I get 50 equals x. So I've just solved for x in this problem. Now let's double check and make sure it works. If I plug in 50 here, 50 plus 5, that angle's 55 degrees. If I double it to get the arc, 55 times 2 is 110, right? 110. So let's plug in 50 here. 3 times 50 is 150, minus 40, yep, is 110. So when I go to check it, I just plug in the value of x and make sure it works. So that's how I'm going to do those problems. Those are fairly straightforward. We're just doubling the angle to find the arc, or taking the arc and half of it to find the angle. Now let's look at some special cases of inscribed angles. Okay, first one. If I have a diameter, and let's call this circle A. Okay, circle A, and I have a diameter going through the center. If I create an inscribed angle with the diameter as one of the sides, what's going to happen is this. I'm going to extend these two sides for a second so you can really see it. What is my inscribed arc, my intercepted arc? My intercepted arc is the semicircle. This arc is 180 degrees. Well, this is an angle that's inscribed in that arc, or in the circle, so that means it's going to be 90. Okay, so let's think through that. 90-degree angle, that means that's a right triangle. So anytime you have a triangle inscribed in a circle where the intercepted arc is a diameter, that's going to be a right triangle. So I've drawn one here, but you know what? It could be the same arc just drawn here. Well, this angle is also 90. What if I intercept it here? This angle is also 90. So all you have to do is look at the intercepted arc. Okay, the intercepted arc is the key. And the concept there is if you intersect a semicircle, that inscribed angle is a right angle. Okay, so we have right triangles. So those will come into play. Now, let's just do a couple quick practice problems. I'm going to give you an arc. I'm going to say this arc is 206 degrees. What is this angle? You can pause it if you need to, but it's just 103. 103 is the inscribed angle, okay? Now, let me reverse it. Now I'm going to give you an angle. Okay, this angle down here is 42 degrees. The inscribed angle is 42 degrees. What is the arc that intercepts it? I extend that side, this arc, I double it, and I get 84. Okay? So that's just a basic overview of those. Plus, Last one of these. What is the measure of angle Y? What's the measure of angle Y? Well, its intercepted arc is a semicircle, so angle Y is 90 degrees. Okay, that's so far so good. Okay, let's look at the time. We need to stop here and make a new video. I'll be right back.